2y squared plus 5y minus 7 completely. How do I factor a trinomial when the leading coefficient is not 1? Chloe is here with her latest tips and tricks. She wants you to know that when you are factoring a polynomial, ask yourself if you can pull out a greatest common factor. She also wants you to know that there are some factoring patterns you can look for: difference of squares, perfect square trinomial, difference of cubes, and the sum of cubes. And her last little tip down here is that when you are raising a power to a power, you actually multiply the exponents together. Now that we have Chloe's tips and tricks, we can go ahead and factor this trinomial. So the first thing that I know is that when I have a leading coefficient other than 1, things are a little bit different. So the first thing I'm going to do is just make my chart. Now the first thing you do is you look at the leading coefficient and you multiply it by your constant. Remember, the leading coefficient is the number in front of the highest degree term. So I'm going to take 2 times negative 7, which equals negative 14. How else can I multiply two numbers together to get negative 14? I could do 1 times negative 14, negative 1 times 14, 2 times negative 7, or I could do negative 2 times 7. Now the next part is to look at your b. Remember, this is in standard form, ax squared plus bx plus c. So your b is the middle term. What is the number in the middle? 5. So when these numbers add up, they have to add up to 5. So 1 plus negative 14 equals negative 13. Negative 1 plus 14 equals 13. 2 plus negative 7 equals negative 5. And negative 2 times 7 equals 5. Now I was looking for it equaling 5. When you add them, multiplied equals negative 14. So this one down here is my answer that I'm looking for. Now I'm going to have a negative 2 and a 7 in my answer, but we're not going to split this into x minus 2 and x plus 7. We can only do that when the leading coefficient is 1. When you have a leading coefficient other than 1, we're going to go ahead and set these up as groups. So our first problem, the problem that we have here, what we're going to do is split that 5y into negative 2y and 7y. So you can see here the negative 2y is because of the negative 2, and then this plus 7y is because of this plus 7 down here. So the only difference that we did was we took this 5y here and split it into negative 2y plus 7y. Negative 2y plus 7y does equal a positive 5y. So all we're going to do now is group them. So I'm going to put parentheses around my first two. So I have 2y squared minus 2y in parentheses. Then I'm going to add and then group second two together, 7y minus 7. From here, now we can look at Chloe's cheat sheet notes and ask ourselves, can you pull out a greatest common factor out of each of these binomials? Well, 2y squared and negative 2y, they both have a 2 that I can pull out, and they both have at least one y that I can pull out. So I'm going to pull 2y out of the first one, and then I'm going to ask myself, 2y times what will give me 2y squared? 2y times y would give me 2y squared. 2y times what would give me negative 2y? 2y times negative 1. On this other one over here, what is the greatest common factor that I can pull out of 7y and negative 7? Out of both of those, I could pull out a positive 7. 7 times y would give me 7y. 7 times negative 1 would give me negative 7. Now, the point of doing this grouping is so that we can find a greatest common binomial factor between both of these. Notice how they both have a y minus 1? That's what we're looking for. So, now that they both have the y minus 1, we can go ahead and pull out the greatest common factor again, which is y minus 1. That's what we have right here, that they both have this y minus 1 part. So I went ahead and pulled that greatest common factor, or the greatest common binomial, out. And what did that leave me with? 2y plus 7. This right here is my final answer.